All right, so we're going to cover some worker pools and generating some XML and Roku feeds for Roku and Amazon Fire so we can deliver that content to those platforms for global search when you open up those devices. So just to give you some context around this, is I work for a startup, Odd Networks, in upstate New York. We're kind of like an integration platform for video metadata and playlists for Vimeo, Livestream, JW Player, Brightcove, and we kind of normalize all that data into a single API, and we have like open SDKs you can use into your own video apps to kind of deliver any kind of content you want. And basically out the other end, you get this kind of Netflix-like app on Roku, Amazon Fire, Google. We have web widgets that you can kind of drop in, and it kind of renders. There's 4 engineers, including myself. The company is 6 total. And a couple of our customers are IT Pro TV, which is courses for like Cisco and Apple that you can sign up and pay a subscription for and take their courses online. Ride TV Go is the one I'm going to use as an example, and they have like equestrian shows, interviews with top horse trainers, and things of that nature. So very kind of like niche video content. So how does actually Roku and Amazon Fire search work? So I don't know if any of you have either a Roku or an Amazon Fire. When you first boot that device, you can go to the general search section and search for your favorite show, whether it's Game of Thrones or Orange is the New Black or Breaking Bad, and it'll give you the results back and says what apps actually contain that show, whether it's Netflix, Hulu, and or HBO Go. How that happens is those platforms give data to Roku, and Roku keeps like a canonical search index of all video content that the channels have. And both Roku and Amazon Fire work the same way. So as publishers of the app, you have to deliver that content to them so that they can properly index and display those search results. So when our customers use our platform, we have to provide those from a platform standpoint and output that XML format to Roku. So there's a sample of like the Roku XML format. Not my first choice for a data format, but Roku's been around for, I don't know, 2002, maybe. And there's documentation on that. And then we have the same thing for the Amazon Fire TV catalog. Much better documentation around that. So you can see kind of like in the XML feed, we have our odd Ride TV Go video 1, 2, 3, 4, 5 with the title, the copyright, and then further down you'll have the description, the rating, and kind of all of that stuff that you can kind of index on. And so the problem that we have is for every client, we have to generate a Roku and a Fire TV feed for every channel that has these platforms submitted to the stores that's based on our stuff. Roku will pull content from us every 4 hours for every channel, and then I think Amazon is every hour. So initially, we started off having just like a generic endpoint where we pass in a token, and we say, OK, we generate the feed, and Roku, here you go. And we started seeing as we started launching more clients, we'd have 10, 20, 30 simultaneous requests from Roku saying, give me content for these 30 channels, which was, we're seeing like, memory limits hitting, also running in Node, so this is why we're at Go now, so everything's going to be in Go. So we just started running into scalability problems, and we decided we had to like rethink the problem a little bit more. So the solution that we started to come up with was, well, why don't we just create a worker pool, set some fixed number of workers that can just kind of churn through these every hour, and we'll just stick these static files on like S3. That way, when Roku and Amazon ask for this, we could just stream that file out to them. Now, there might be, depending on when Roku and Amazon hit us, there might be like an hour delay. Maybe some video items might not be in there. But we're talking about these really niche kind of small video titles that might not need to be completely up to date. As soon as they publish, it doesn't need to be immediately indexed in Roku and Amazon. So here is like a sample how we kind of like start the pool. And we pass in how many workers we want and how long we actually want this pool to sleep between running through all of these jobs. And then I also pass in a logger and a store where we can get all of the content from. And so I just kind of set up a channel just to pass the platforms across, and then I run through and start a bunch of workers. And then further down the bottom is I start to just endlessly loop and go through and scan and pull every platform out of our database and start sending those platforms across the channel to the worker. And then it'll start to block because we only start up like maybe 5 or 10 workers. But once we churn through all of those, that loop will just sleep for like an hour, and then it'll just start all over again and then run through the entire list of platforms again. So on the worker side, we create just a generic feed struct, and then we have the collections being like playlists or a season, series, or episodes, just like a group of other items. And then we just kind of like iterate through everything and generate that whole feed for it. And then at the very end, we start up a pipe that we then encode the final struct feed into the XML encoder and then stream that right to S3 into the bucket. And that's all that this is doing every hour of the day. It's just like firing through all these platforms all at once for both of them. And then in the main program is kind of where we set up all of our configurations. So we'll pull from Dynamo, and then we'll set up 2 different pools, one for Amazon and one for Roku, and then just start like pumping these platforms across. And then the results is we have, here's like a snippet of the log where we started, and I kind of keep track of how long these things kind of take. So it takes about, we have about like 50 feeds right now, so it's about 15 seconds just kind of like go through all of them and get them to S3. And then on the other side, we have like a public API where we just have a URL where we can hit the right TV Go XML feed, give it a token just so we can verify that it's coming from a trusted source. And we're actually running this feed service on a $7 Heroku dyno, so it's nice and cheap. Average about 40 megs of memory, which is nice. I'm sure there's like some optimizations. I think I wrote this in like a day. So I just haven't spent time to like play around with it anymore. And the largest catalog we actually have is a 25,000 line XML file, and it only takes about 7 seconds to do. The big takeaway from that was doing the streaming. So you're not holding that entire JSON or XML like in memory and then shoving that all over to S3. So that's kind of where we went with that. So the takeaways from this is, like I got that worker pool pattern from the advanced Go concurrency patterns. It just seemed to fit well. The piping was a nice find. I didn't actually know that existed. Coming from the Node background, there's like a lot of streaming and stuff like that. So that was actually fine. And the encoding itself is just usually pretty trivial. So to give you an example of like what these channels actually look like. So this is our web widget. It's a single JavaScript file. You drop it on a web page and just render out this entire feed. So we need to provide Roku all this metadata so that it can search this channel when you open that up. So this is like the web version, and then you can even go over to like the Amazon.com store and search for Ride TV. And this is the Amazon Fire. That's the Java built version. They look pretty much identical. So that's kind of all I got. It was just kind of fun, stream a file. Appreciate it.